Hello guys, welcome to Big Book. Today we are going to study about karyotype. First few slides we will discuss, we go through the definitions and then we will start the discussion. The first slide says the study of whole sets of chromosomes is sometimes known as karyology. Here we know the study of set of chromosomes, that is the metaphysic chromosomes. This study is called to be as the karyology, and in the second slide we are going to read the definition. A karyotype is the number and appearance of chromosomes in the nucleus of a eukaryotic cell. Here the definition describes about the chromosomes in the nucleus of a eukaryotic cell, that is the chromosomal complete structure in the eukaryotic cell during the metaphase. But here this definition is not the correct definition. The next definition is the chromosomes of a cell usually displayed as a systemized arrangement of chromosomes pairs in descending order of size. So here this particular definition gives somewhat the description about the karyotype, that is the systemized arrangement of chromosome pairs in descending order of size. This is also not a complete definition. The next definition is the characterization of the chromosomal complement of an individual or a species, including number, form and size of the chromosome. This is also one of the definition, but this definition gives the complete information, but we can't consider this particular definition even. This definition is the number, size and shape of the chromosomes of a somatic cell arranged in a standard manner. So here this particular definition gives the complete information about the karyotype, how a particular karyotype has to be standardly arranged to make it appear in a correct way. So coming to the next slide, attention is paid to chromosome length, the position of the centromeres, banding pattern, any differences between the sex chromosomes and any other physical characteristics. The preparation and study of karyotypes is part of the cytogenetics. In this particular slide, we have gone through that the chromosome has to be arranged according to the length, that is the homologous chromosomes has to be arranged according to the length and the position of the centromeres. Banding pattern, if we are going to consider different kinds of the banding techniques, and any differences between the sex chromosomes. Usually we will be having the differences between the sex chromosome depending upon the sex of the individual within the species, and any other physical characteristics, that is it can be the difference in the appearance of the size of the both the arms, that is the P arm and the Q arm of the chromosomes, and also the presence of the secondary constructions, and also the presence of the satellite bodies, like this. The preparation and study of karyotype is the part of the cytogenetics. This is the well-known statement. Next is the first is in the karyotype is the absolute sizes of the chromosome. This is the very important point. The next slide says the position of centromeres. The position of centromeres is also going to play a major role in the arrangement of the karyotype in a standard manner. Coming to the next slide, the human karyotype contains 22 pairs of autosomal chromosomes and a pair of sex chromosomes. That is, in the human karyotype, the autosomes will be in the 22 pairs and also a pair of sex chromosomes. If we consider pair of sex chromosomes, it only fits for the female individual, whereas for the male the sex chromosomes can't be said as the pair of sex chromosomes, whereas the X chromosome is different from the Y chromosome. Coming to the next slide, the normal karyotype for a female contains a pair of sex chromosomes, whereas the normal karyotype for the male contains an X and a Y chromosome. This is as discussed now in the previous slide. The next is the, in this slide you can observe that the chromosome karyotype. This has been seen that this is the human karyotype of a male, where you see the first group, second group, and the third group, fourth, fifth, sixth, and seventh group of the chromosomes. And here this is the male karyotype of a male human being. That is, the last pair of the chromosomes is X and Y. Now we will discuss few more points which are very important to make a standard manner of the arrangement of the karyotype is going to be depending upon the centromere, that is the any chromosomes with their size and position of the centromere, that is the metacentric or sub-metacentric chromosomes are going to be grouped together always, but the size is going to play a major role within the formation of the karyotype or the arrangement of the karyotype. So here first we are going to consider the size of the chromosome, then the centromere position. So here, as we have already discussed about the size, that is the in the decreasing order of the size or the manner of the size, the karyotype will be arranged. In this, main role is going to be played by the centromere, where according to the centromere position we are going to take the homologous chromosomes. That is, the first we have to consider the size, and the second is the arrangement of the chromosomes according to the position of the centromere. So after taking the chromosome, the homologous chromosome has to be searched from the metaphysics picture or the photography, where we are going to consider the size first and after matching the position of the centromere. So here in the metacentric form, we are going to consider both metacentric and sub-metacentric as the similar but with little difference. That is, centromere is median or near median is called to be as the metacentric, and also the chromosome has two well-defined arms with a length ratio varying from 1:1 to 2.5:1. That is regarded 1:1 is regarded with the metacentric, and 2.5:1 is regarded is to be as the sub-metacentric. A slight difference in the central or the median position of the metacentric position of the centromere is going to be related to the sub-metacentric position. Coming to the next slide, acrocentric position of the centromere. Centromere is close to one end of the chromosome. So here the centromere is going to be completely shifted to the one end of the arm of the chromosome. It means the whole chromosome will be having the whole chromosome is going to have a single large arm, whereas the other arm will be very tiny. One of the arm is substantially smaller than the other, and the arm ratio ranges from 3:1 to 10:1. So here this is how the arm ratio is going to differ within the acrocentric chromosomes. Next is telocentric. In this, centromere is a strictly terminal entity and the chromosome is one armed. So here completely the centromere will be at the terminal point or the polar point of the arm of the chromosome, so the other arm will be absent. So chromosomes are always arranged with the short arm on top. So here chromosomes are always arranged with the short arm on top. Here the chromosomes will be having the single arm. Short arm is labeled to be P French petite, long arm is labeled to be the Q. So this is the one, and other is, next is the how the Paris nomenclature is going to consider a particular karyotype. That is, it is going to consider a particular karyotype of a species is by the total number of chromosomes, sex chromosome constitution. Sex chromosome constitution in the, it is regarded with the how a particular sex chromosome has going to have a particular length of a arm or both the arms, position of the centromere, and other any secondary constrictions or any satellite bodies or any other things, and also description of abnormalities, that is 46xx normal female and 46xx normal male. In this sense, description of abnormalities, if we are going to take a particular healthy human being and if we are going to prepare a karyotype, then the healthy human being's karyotype will be having a normal karyotype of 46xx, normal female 46xy, normal male. But if there is any abnormality related to the any kind of the chromosomal differences, that is, it can be in the number of the chromosomes, it can be in the shape of the chromosomes, it can be in the size of the length of the chromosomal arms, or it can be in the difference in the position of the centromere, all has to be described. Okay, that is how a particular Paris nomenclature is going to describe the karyotype. So here in this slide you can observe that a human karyotype of a normal female has been given. That is, in each pair they have shown 3 chromosomal appearance. It doesn't mean that humans have chromosomes in 3 in pair. We are diploid in nature, so 2n is our diploid. 2n is equal to 46. So here they have shown 3 number of chromosomes. One is the picture depiction of the banding they have shown of the different G banding, and the other 2 which has been shown after the first chromosome is of the real image of a microscope. So here, like this, every pair has been described. Coming to the next slide, human chromosomes are divided into 7 groups and sex chromosomes. So here, when we have observed the previous slide, in that we have observed that the human chromosomes has been divided into 7 groups. That is the group A, B, C, D, E, F, G, and the sex chromosomes. So here, when we are going to consider, A group will be having 1, 2, and 3 large metacentric chromosomes, whereas certainly 1 and 2 certainly will be sub-metacentric also. So here majorly it is considered to be as the large metacentric. Group B will be having 4 and 5 large sub-metacentric chromosomes, all similar in size. So here A group will be having the large chromosomes which are metacentric, whereas the B group will be having the smaller chromosomes compared to the A group, which are large again, okay, which are large again but smaller than the A group, will be sub-metacentric. All are similar. There is no difference in the centromeric position. But in group A, sometimes there will be, sometimes or always, the first and second may appear to be as the sub-metacentric. The C group will be having 6th, 7th, 8th, 9th, 10th, 11th, and 12th chromosome. So apart from this, X chromosome will be included in the C group. In this, these are medium sized, so it is smaller than B group and the A group, but sub-metacentric and difficult in the appearance of the banding or the any type of the staining techniques. So here these are going to have the highly concentrated heterochromatic regions. So here difficult to make out, and the D group will be having 13, 14 and 15 medium sized acrocentric plus satellites. So here in the D group we observe the satellite chromosomes. So coming to the next slide, E group will be having 16, 17 and 18 short metacentric chromosomes. 16 is the short metacentric, but the 17th and 18th is the short sub-metacentric chromosomes. Here these are smaller than the D and C, A, B, C and D group chromosomes. Okay, here they have arranged the short metacentric the 16th chromosome, and the sub-metacentric is 17th and 18th chromosomes. F group will be having 19th and 20th short metacentric chromosomes, and the G group will be having 21st, 22nd and Y chromosome. So here this is the last group of the karyotype where this has been arranged. So here 21st and 22nd are short acrocentric with satellites. Y chromosome doesn't have any satellite body. Now here this is how a particular karyotype has to be arranged. This what we have discussed is regarding with the normal male or the female karyotype. We can arrange these particular chromosomes where the X is going to be present in the C group and the Y is going to be present in the G group. Now here coming, what is the significance of a particular karyotype? Karyotypes can be used for many purposes, such as to study chromosomal aberrations. You know what is chromosomal aberration? Chromosomal aberrations are a particular chromosome is going to be due to some sudden changes, it is going to be going to lose any kind of the genetic material that we called as the deletion aberrations. If the genetic material is going to get duplicated twice during the replication of the DNA, then that is called it to be as the duplication. If a chromosome is going to break in any part of the length and it is going to get reversed and attached within the chromosome, here we called it to be as the inversions, and like that the translocations is also be observed. That is a part of the chromosome of a different homologous pair is going to attach to the different homologous pair. That is also can be understood. And also apart from this we have studied about the syndromes. Okay, in that also this will be very much helpful to study a particular karyotype, which is going to be helpful to understand a particular individual's genetic material with the help of the karyotype. Later the further actions can be taken. Cellular functions can also be understood depending upon the karyotype. Taxonomic relationship. So here taxonomic relationship is like in the research field where the evolutionary or where a particular chromosomal set can be fit within the taxonomic strategy, or the taxonomic strategy can also be understood, and to gather information about past evolutionary events. Of course, with the help of this karyotype we can understand the past evolutionary events. There are species which resembles within the karyotype and the genetic material very closely related. Due to the evolutionary action, there will be slight differences even in the karyotype, that is in the genetic material and also in the appearance of the karyotype. That also can be understood. Coming to the next slide, different characteristics of karyotypes are usually observed and compared. So this is the normal procedure adopted to understand a particular karyotype. In the sense, after arranging a karyotype in the standard manner, these are the 6 different things which will be observed and compared within the karyotype. The first one is difference in absolute size of chromosomes. As we have already discussed that the karyotype is first main parameter is that the size of the chromosomes will be addressed, then the centromeric position will be addressed, and then the homologous pair will be made. So difference in absolute size of the chromosomes can describe many things. That is the, as we have discussed in the early slide, that is the karyotype significance, that is the aberrations, cellular functions, taxonomic relationship. Like this we can describe all those things. So if there is any difference, we can make out the things very easily. Next is difference in the position of the centromere. Difference in the position of the centromere definitely gives a additive advantage to decide that the chromosome has taken part in any aberration or the any evolutionary action. Like this aberration, you know that deletion, duplication, inversion, translocation will be causing the difference in the particular centromere of a particular chromosome. So like that, the difference in the position of centromeres can be read in the karyotype. Third is the differences in relative size of chromosomes. These differences probably arose from segmental interchange of unequal lengths. So this particular point describes that interchangeable of unequal lengths, that is the translocation, or it can also, of course it is a translocation, which we have already known that translocation will cause the difference in the particular size of a length. That is, the translocations will take part between the two different chromosomal sets. That is, the one homologous set, a part of the chromosome of that is going to get attached with the different homologous set of the chromosomes. So this is how this can also be understood. Further is differences in basic number of chromosomes. So here differences in basic number of chromosomes, that is the basic number of the chromosomes is what we have already known, diploid nature, that is 46 number of the chromosome, that is XY and XX. So when there is a difference in the basic number of the chromosomes, it can lead to any kind of the syndromes also. That is, the Down syndrome is there, Klinefelters syndrome is there, and if we consider many other syndromes is also be seen. Next slide is differences in number and position of satellites. Satellites are small bodies attached to a chromosome by a thin thread. Of course, certain times the karyotype after arrangement, we will not be able to see the satellites as we have described in the G group. There will be the satellite bodies in the telocentric form of the chromosomes, but certain times, due to the certain differences or operations caused, the small bodies will not be present. That also can also be observed. Sixth is differences in degree and distribution of heterochromatic regions. Of course, this is also a very important point. That is, if you want to describe any deletion or duplication or inversion within the chromosome, this is very important point, that degree and distribution of heterochromatic regions has to be observed. That is, there is a banding technique called to be as the G banding, which gives the thick banding at the heterochromatic regions, because this G banding causes the GC regions get stained. So here, due to which the particular that GC rich, that is guanine and cytosine bonding regions or the chromatin regions, get thick in stain. So the banding is going to appear thick and definitely a band is going to form at that regions. So with the help of this degree and distribution of heterochromatic regions, that is going to describe how the chromosome is present. Now the next slide is going to describe about, of course from here we will discuss about the certain techniques which is used very briefly. That is, cytogenetics employs several techniques to visualize different aspects of chromosomes. So here, first technique is G-bending. Is obtained with Giemsa staining following digestion of chromosomes with trypsin. Trypsin is an enzyme which helps in digestion of certain non-histonic part of the chromosomes, that is going to lead to the staining of the GC regions. It yields a series of lightly and darkly stained bands. The dark regions tend to be heterochromatic and the light regions are tend to be the euchromatic, late replicating at 80 rich regions. And further, the next is the R bending, is the reverse of the Giemsa bending. That is, here whichever the dark bands has formed in the Giemsa staining technique, there the bands are going to become lighter, and wherever the 80 regions are present, those 80 regions are going to become the dark bands. So here this is how the reverse banding is going to be formed. And further is the C banding. C banding is the centromeric binding. Again, it is done with the help of the Giemsa, where Giemsa binds to the constitutive heterochromatin, so it stains centromeres. So here this is particularly a different kind of the banding compared to the Giemsa and the R banding. So here a particular staining technique will be considered, and here the C banding causes a dark stain at the centromeric region, and it makes the centromere to appear very brightly with the help of the stain. So guys, this is a brief account and the description about the karyotype and how the karyotype is formed and how the karyotype has to appear, and what are the basic observations we have to do, and what are the significance of the karyotype, and also what are the some simple techniques will be used to stain the chromosomes to observe and get photographed and to arrange. So thank you guys for your kind help and watching this video. Be tuned, we will come back with a new topic. Thank you.